Alright, today's video is about graphing proportional relationships. The first thing that you need to know is when is a graph proportional? And if you remember from the notes that we took, a graph is proportional when the line goes through the origin or 0, 0. Okay? Easiest thing you need to know about graphing proportional relationships. If it's proportional, it means it goes through the origin, which is 0, 0. I'm going to do a few practice problems. So the first one we're going to start with is this one right here. So what we can do is, look at this graph. Obviously, we can tell that it doesn't go through the origin, but just to make sure, we are going to look at some of the points that it hits. This basically means we're going to follow this line and see anywhere that it hits right in the center of 2 points. So at 2, 2 would be a point, so I'm going to put a dot there. At 0, -4, I'll put a dot there. And let's see, I can go 4 and up 8. Okay, just a few numbers that you should look for, so that way you can tell if it's proportional. Sometimes it's really easy because obviously it doesn't go through the center, which is right here of the graph, but just in order to make sure, because sometimes you won't have it completely all the way to 0, 0 or near 0, 0, so you want to make sure that you find some of those points and see if there is a difference. So I have 2, 2, I have 0, -4, and then I have 4, 8. Now you want to put these in order, so I accidentally put 0, 4 second, so you want to make sure it goes 0, 1, 2, 3, 4, in order. So I can see that between at least 2 and 8, there's a big gap, which is 6. Okay, so we're going to look at a different graph. So this is not proportional because it doesn't go through the origin. Okay, so let's look at a table now. And if we look at this table, we can see that it kind of increases at a constant rate, but let's graph it first. So I am going to zoom in a little so you can see. So looking at these points, I know exactly that this is x and this is y. Okay, x is always first, y is always second in a table. So I know that this is the x-axis and this is the y-axis because the horizontal is the x and vertical is the y. So I'm going to go over 2 and up 3 and put a dot. I'm going to go over 4 and up 6. I'm going to go over 6 and up 9. And you can tell that I can't go any further, which is perfectly fine, so I can stop plotting at this point. If my graph was larger, I could plot all the way up to 15. So the difference between 3 and 6 is 3. The difference between 6 and 9 is 3. The difference between 9 and 12 is 3. And the difference between 12 and 15 is 3 as well. If I look on this side, I can see that it's increasing from 2 to 4 plus 2. And from 4 to 6, it's plus 2, and so on and so forth. So I know that this is consistently increasing by the same amount on both sides. Now if I wanted x to be 0, what I would do is, because we're increasing by 2 each time, I'm going to decrease by 2 to go back to 0. So I'm going to put this actually at the top here. I'm going to put above it. So if I go -2, I get to 0. Okay, I know that this is increasing by 3, so I can go backwards -3 and get 0. So this is saying that x and y will both be 0, 0, which is right here. So I'm going to take my ruler and I'm going to graph it. And as you can see, the graph is proportional. This means that it goes right through the center of the origin, or 0, 0. Okay, we're going to try another example. We're going to look at this graph. Okay. So as you can see, let's plot some points. So I have 0, 0, easy enough, 1, 1, 2, 2, 3, 3, 4, 4, and so on and so forth in that direction. What I'm going to do now is go the other direction, so I have negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4. Oh look, it's perfectly even amounts. It's increasing by the same amount. So if I was going to create an x and y table, just to verify, I can go negative 2, negative 1, 0, 1, 2. I usually try to, when I am graphing and if it's going into the negatives of x's, I would prefer to do negative 2, negative 1, 0, 1, 2, and so on and so forth. But these are the 5 main ones that you need to show. So at negative 2, 2, we have negative 2. At negative 1, I have negative 1, 0, 0, 1, 1, 2, 2. So this is increasing on the x, plus 1, plus 1, plus 1, and so on. This over here is increasing with a plus 1 because we're taking away 1. Or sorry, giving 1. Okay, so this graph is proportional. Woo! Easy peasy lemon squeezy, right? Alright, last one. Proportional or non-proportional. So now we have a table. So what's going to happen is, I'm going to look at these and go, first, what is my x increasing by? Let's see. It is increasing by 1. Now, to determine if it's proportional or not, you can't really tell by the x's. That's not what we're looking for specifically, but we want to know that it increases by 1, so in case we want to find other numbers like 15 or 45, we know that whatever the previous number was plus 1. Moving on the y-axis, it looks like we are increasing by 5, because from 5 to 10 is plus 5, from 10 to 15 is plus 5, from 15 to 20 is plus 5. So this graph is going to be a little small, so I'm only going to plot a few of the points because I don't have all the way up to 20. So I'm going to take 1 and go up to 5. I'm going to go from 2 to 10. And this is going to be really steep. Okay, obviously you can see how steep the line is. You can determine how steep it is by as it gets closer to the y-axis. The more steeper it is, the closer it'll be. So again, if I wanted to go backwards, I would subtract 1 because I'm increasing, so I'm going to do the opposite, which would give me 0. Okay, instead of adding 5, I'm going to go backwards 5, and I'm going to get 0 as well. It's always good to find the previous point, just so that way you are aware of where your graph is going to go. So, let me ask you, this is proportional or not proportional? It is proportional.